Now that you've done DIY number 4, you can use this key video to check your answers and jot down any questions that you might have for Mr. Singer and myself. Number 1 says, which of the following is true concerning the mean absolute deviation of a set of data? Well, remember in the notes video when we talked about mean absolute deviation, we talked about the average distance between each data value and the mean. So we can already eliminate a lot of answers. A talks about median, and we don't deal with median here, or we don't deal with mode here. So median mode is automatically out. And B leaves out that average distance between each data. We definitely don't use the absolute value of the mean itself. So B is incorrect. So the only option we have is D. So it describes the average distance between each data value and the mean. Alright, so the table shows parking prices at various beaches along the Texas coastline. So we have different parking prices. We have $2.50, $3.75, $1.25, $2.25, and $3. And this question wants us to find the mean absolute deviation for the data set. So the first thing we got to do, we're going to use add sad. So we've got to add. And so I opened up Desmos and I already added them together and got $12.75. And then now we got to divide. And there's 5. So we're going to divide by 5. Okay, and that gives us $2.55. $2.55. And so we put that in parentheses, in our parentheses spot. And so now we're going to take each data point and subtract our mean. So this is our mean right here. Okay, so we're going to take each data point and subtract our mean. And remember, we're taking the absolute value of that as well. So we're going to do 250 minus 255, 375 minus 255, 125 minus 255, 225. Let me fix that. Let me fix that 5. 225 minus 255. And then $3 minus 255. And I already did that down here as well on Desmos. I got 5 cents. 5 cents. So I got $1.20. So you should have got $1.20. $1.30. This is 30 cents. And this is 45 cents. So I'd add all those together, which I did. 5 cents, $1.20, $1.30, 30 cents, and 45 cents, and I got $3.30. So I've subtracted. Now I'm adding again. $3.30. Now I'm going to divide one last time. Divide by 5 because there's 5 points. And that should give me 66 cents. Okay. And this is your mean absolute deviation. Number 3. Stats for 2 softball players are below. So Kaylee and Tasha, their average hits per game are the same. They're 3. But their mean absolute deviation per game is different. So Kaylee hits 8/10 for her mean absolute deviation, and then Tasha's mean absolute deviation is 1 7/10. So although they both average 3 hits a game, Tasha has a higher mean absolute deviation on her hits. Finish the sentence stems to explain what this means. Kaylee's mean absolute deviation is lower than Tasha's. This means that, so remember in the video Mr. Singer talking about the two classes, the students had the same average, but one's mean absolute deviation was smaller than the other ones. And so when we're talking about the lower mean absolute deviation, that means the data values are closer to that average or that mean. They aren't spread out, so they're very consistent. So Tasha here is very consistent with her hits, so she is getting the closest to her average each game. So pretty much she is only, this means that her data points are either 8/10 below her average or 8/10 above her average. So she is very close to her average here. So I'm going to say this means that Kaylee's hits are more consistent and her data values are closer to her average. There we go. Number 4. What is the mean absolute deviation of the following data set? So we're going to add again. So we're adding all those numbers, which I did, 192. Okay. And you can use Desmos or you can use your phone calculator, but just make sure you're writing out each step so you're keeping it organized and not getting lost, because even though it's simple adding, dividing, subtracting, adding, dividing, you can get lost. There's a lot of steps. So 192 divided by our data, which is 6, and then this is 32. So I'm going to put 32 in here. So this is our mean again. So now we're going to subtract our data points, our data values, from our mean. So 23 minus 32, 24 minus 32, 29 minus 32, 30 minus 32, 38 minus 32, and 48 minus 32. So we have 9, 8, 3, 2, 7, not 7, 6, and 16. Okay? And then we add those together and we get 44. 44. And then we divide that by 6. Okay? 44 divided by 6 is 7 3/10, because I'm going to round, so 7 3/10. So that is your mean absolute deviation. Alright, so I'm going to erase this side of what I've written down so I can do for number 5. So number 5 says the weights of several adult guinea pigs are 33, 39, 42, 33, 39, 31, and 32 ounces. Find the mean absolute deviation and then describe what the mean absolute deviation tells you about the data. So I also added all of those together here, right here. So 249, so if I add all those ounces together, you get 249. We're going to divide by the amount, so 1, 2, 3, 4, 5, 6, 7. And that will give us 35. And I'm going to round to the tens place. You might have rounded differently, so your answer might be a little bit different than mine. But on the quiz, we will definitely tell you if we want you to round to the tenths or the hundred place or the nearest whole number. So now I'm going to take each data value and subtract the mean again and take the absolute value of that. So 33 minus 35.6, 39 minus 35.6, 42 minus 35.6, 33 again minus 35.6, 39 again minus 35.6, 31 minus 35.6, and then 32 minus 35.6. Alright, so now I go over here. I have them down so I can tell you. So this is 2.6, this is 3.4, next is 6.4, we have 2.6 again, we have 3.4 again, and the last two are 4.6 and 3.6. Okay, so now if I add all those up, I should get 26.6. Now, like I said, your answer might be different if you rounded differently, but our mean absolute deviation should be around the same ballpark. So if I divide that by 7, this gives me 3.8. So that's our mean absolute deviation. And what does that tell you? Well, that tells you that every data point is either 3.8 lower in ounces. Every guinea pig's weight is either 3.8 lower than our 35.6 or higher than our 35.6. So that's the distance. So this is the distance between the mean and the data points. So that's what this mean absolute deviation tells you about our data here. So number 6, the table below shows Leland's bowling scores during 2 different months in his bowling league. Find the mean absolute deviation for each month, round to the nearest tenth, and then write a few sentences comparing their variation. So I'm going to do April over here, and then May over here. Alright, let's do April first. So if I add all those numbers up, which I put it in my Desmos calculator, we get 620. Okay, 620. Then we divide it by our data values, which is 6. This will give you the mean, which is 103 3/10. So we're rounding to the tenths place. This is the mean. Alright, now we're going to take all of our data values and subtract it from our mean, and then take the absolute value of that. So 98 minus 103 3/10, 103 minus 103 3/10, 116 minus 103 3/10, 95 minus 103 3/10, 90 minus 103 3/10, 118 minus 103 3/10. Okay, and if I do each one of those, I get 5.3, 5.3, 0.3, 12.7, 8.3, 13.3, and 14.7. So I add all those up, and I get 54.6, and I divide that by 6, and I get 9.1, which is our mean absolute deviation. Okay, so now we're going to do May. So I'm going to erase all of this so I can use this side for May, so I don't have to switch everything. Alright, so I'm gonna add all those data points for May up now, which I did, and I get 735. And I divide that by 6, and I get 122.5. So that is my mean, or average, for May. Okay, so now I'm going to do the same thing I did for April. 112 minus 122.5, 118 minus 122.5, 145 minus 122.5, 130 minus 122.5, 125 minus 122.5, and then 105 minus 122.5. So if I subtract those and take the absolute value, you should get 10.5, 4.5, 22.5, 7.5, 2.5, and 17.5. Okay, so if I add all those up, I get 65. And if I divide that by 6, I get 10 and 8 tenths. So that's our mean absolute deviation. So now it says then write a few sentences comparing their variation. Okay, so the variation is the distance between the mean and their data points, which that's what we found with the mean absolute deviation. So if we want to compare, we can say that in April he had a lower mean absolute deviation, which means that he was more consistent with his data. His scores were more around his mean, versus May, where he had a higher mean and his mean absolute deviation was higher because his scores were more spread out. So that's how you do number 6. If you have any questions, you can ask Mr. Singer or myself in math tutorials or math